So, James, you've had quite an elaborate career in the hardware industry, in and out of various software companies and providers. What do you see as some of the biggest evolutions since you started your career to where we are to today?
I think the biggest shifts I've seen in my PLM career is the changes that have occurred in industry, meaning the manufacturing industry of all kinds of hardware products, automotive, aerospace. Back in the day, we might say that not too long ago, that companies were, as was called, vertically integrated. Mm-hmm. They made everything. A lot of my career with HP, Bill Hewlett, Dave Packard made every single thing in their hardware product back then that founded the Silicon Valley. Today, there's a vast supply chain, an ecosystem that's global. It's beyond our boundaries of the United States. And so now companies can draw from that ecosystem and buy modules and full products that wasn't possible before.
And so what do you think was the catalyst for that change?
Often I think it was a business catalyst. Large corporations have a huge investment in their people, their capital assets, the things that are inside a factory. And when there's rises and ebbs and flows in demand for products, that's a heavy burden. When sales go down of cars and planes and things, you've still got to pay full-time employees and run those factories.
So
and it costs money to
the capital equipment costs, the inventory costs.
Exactly, all of that, because it was sort of a sunk cost,
right,
plus employees. So, and then it's dangerous or difficult to shed staff, then have to rehire.
Right.
You get hubs, automotive hubs like Detroit and Stuttgart area in Germany. And you lose a lot of intellectual property if those people move on to different industries.
And so do you think, what forced the change? Was it the business decisions and the expenses, or was it that the technology itself started to change to permit this new model of outsourcing?
Yeah, and I think it's a confluence of events like that. Cloud computing, mobile technology, the power of computers, desktop and mobile. The big OEMs were incented to have a variable workforce, so they could transfer a lot of that co-development into the supply chain and treat the cost of those modules and those components as an expense of the product. Just buy less, they don't incur any termination fees of employees, and they don't have to retrain new people. So it's sort of placing the burden of these economic ebbs and flows into the supply chain. And the supply chain evolved to be able to have their own intellectual property and build their own sophisticated modules and products themselves.
And so do you think the technology itself, like the internet and communication tools and video conferencing tools, now makes it easier?
Totally. That was a big trigger. If, let's say, some of the automotives in like Dearborn, Michigan, if all the suppliers had to be orbiting around that hub, that local geography. Now, with the availability of internet, you can access a global supply chain. And no matter where you are, you can work anywhere, build anywhere, and that boundary is gone.
And what about time? So when things were more in-sourced or built in-house, what was the estimated or expected time to set up your infrastructure, to have your supply chain ready,
Sure,
and even to get your product into market? What were some of those time frames at the time?
Often years, to be frank.
And that was acceptable?
It was a lot of the big industries were sponsored by governments. Think back to my time in Asia, Korean automotives just starting. One of the biggest inhibitors I remember that we couldn't overcome was a lock industry. Korea didn't have a history of making locks, whereas Germany, Europe did. So they couldn't make cars because they didn't have a lock industry. That had to be created before they could make a domestic car, and that was required before they thought about exporting cars.
And so it seems like a lot of investment, upfront investment, was needed before any products can be sold and any revenue can actually come in.
Absolutely.
So hardware was a very, very risky endeavor. There was a lot of capital expenses, a lot of capital funds that needed to be in place before you can even get to market.
Totally. And now, like I mentioned, the OEMs kind of cultivating this very sophisticated supply chain. They are in themselves producing very sophisticated modules or full products. So the downside of that is, yes, it provides this variable workforce and discretionary how much you want to buy. The downside is that a lot of that intellectual property now belongs to the supply chain and not to the OEM. Think about blind spot assist in a car or airbag technology or these kind of things. Those are not core competencies of the traditional industry that makes cars and planes and even computers.
So I want to get back to time to market. You mentioned that it can take several years before the first production unit comes off the line.
Yeah.
Today, years is an eternity.
Yeah, you bet.
Companies are started and folded within a year or 2 years, right? And so, do you see that as a good thing, that the pressure to get products to market has been increased and that it's no longer acceptable to take years to get to market? Or do you think that actually puts undue pressure on companies to deliver products sooner?
It's both, and the consequence of that is that new companies emerge. Those that are free from the corporate governance of a traditional company, designing, building things the way we've always done it and trying to catch up. A new startup suddenly emerges who can access that same supply chain using modern SaaS cloud-native tools without having an IT department, without having to stand up a database and buy servers and all this stuff. They can rapidly go from an idea in a college dorm room into forming their little company to getting the attention of investors, making that first product cobbled together in their dorm room or whatever, proving something works, and then rapidly scaling from there without any capital assets. They don't own any desks, no office space, no capital equipment or test machines or anything like that.
Yeah, I think there's market pressures that I say started from the software industry. So in recent years, software products, web applications, mobile applications, can be launched in a day. Right? Very simple applications, the tools are mature, the processes are in place, the infrastructure is there for a handful of people with an idea to develop a product and launch it to the world in days, right? Weeks, right? And then to make updates to those products, it also can take a day, an hour, or a very short time.
Right.
I mean, it's not unusual, you wake up in the morning, you look at your phone, and it tells you you've got 22 apps that need to be updated, right, every day. So it feels like the market, the consumers of these products, the software products, now have an expectation that all products should be able to be released in a much more rapid and short period. And it feels, as someone who's in the hardware industry now, that some of those pressures are coming into our market as well. And so hardware companies, whether it's an industrial product, a consumer product, space tech product, have this pressure to come up with the idea and get it to production now in months, not the years that we once were permitted to.
Yeah, totally right. I mean, as consumers, we're driving a lot of that demand. The expectations of what we're now familiar with of apps on our phone and mobile banking and navigation, where we don't want to wait years for that new car. We expect there to be a new model variant every year.
And so that pressure, it's kind of an Ouroboros. It's, what started first? Was it the distribution of resources so that hardware companies can now move faster, or the market pressure to force companies to move faster, or the technology is now prevalent to even make that permissible, right? And so that's something that's really exciting, is the risks and the overhead to manage hardware were often a contributor to some of those elongated timelines, right? The manual processes, the time it took to set up the infrastructure, to procure the equipment. Those are all now gone. Like they're being removed and replaced by software technologies, by cloud native tools, by APIs, by distributed communication tools.
Yep.
Right? And so now it's even possible for hardware companies to be able to set up their infrastructure, pick their teams from distributed resources around the world, and have their entire tool chain up and running in a few weeks.
Right, it's very true, and you know, most of my career in PLM was with traditional PLM companies that evolved out of the heavy industrial industries like automotive, aerospace, and so on, and they were architected to work with that presumption that the design originated in this mechanical CAD system, and then simulation, and then PDM, and then electronic. But hardware is kind of unique in that, you know, you correctly identified the software industry works very differently. And although the traditional PLMs have been attempting to bring agile methodology, it's just not native. It's not possible with the architecture of how those systems are. Hardware really is at the intersection of industrial products and software, in that hardware comprises a lot of procured in electronic devices, procured transistors, capacitors, you know, IoT devices. It's got firmware on board, and it often has software, and it has software services from a cloud service. So the nature of how a piece of hardware is designed is often driven by software. When we're buying, even now it is coming sort of reverse gear into the traditional. If we're in a showroom looking at cars, we often look at the infotainment center and the feature list, which is all hardware. We're not studying the weldments under the floor pan or suspension springs or coils to make our buying decision.
Right. Well, what I like is that those once high walls between the hardware teams and the software teams and companies are now gone.
Yeah.
And they're both looking over that wall and saying, hey, what are you doing? I'm really curious about what you're doing now, and how can we work together? How can we bring software workflows into the hardware industry? And as a software developer, I love to learn more how hardware is built so I can design my software to be more compatible. Right? It feels that it was once you were a software company or a hardware company, but now it's more common for the current term is IoT. But I feel like the concept's been around for a while. It's gone through several different names. But the fluid transfer of information and knowledge and collaboration between software and hardware is much more linked these days, and much more cooperative and collaborative to build a final product.
It totally is. But what it brings to mind is why hasn't everybody gone there? It's been talked about, agile methodology has been talked about. How does the manufacturing of hardware and physical products emulate the software industry, which has been doing this for decades? It comes down to organizational constraints, the human factors, the human organizations that are vertical, and they do their work and they pass it over the wall to the next organization, which works on it. So notwithstanding the capability of modern cloud-native solutions and examples of hardware companies doing agile product development in record time, there's a lot of legacy companies that are unable to, and their reaction to that is setting up new spin-offs or spin-outs or tiger teams or remote disguised kind of corporations funded by the big OEM to build that new EV, that new electronic vehicle, or that new heads-up display or something like that.
Well, it seems some of this is rooted in, as we were discussing earlier, the acceptance of it taking months or years to set up your infrastructure. So it wasn't expected that tools, your software tools to develop hardware would just work out of the box. It was understood that there was some labor associated with setting it up, configuring it for your company's workflow policies, and also any kind of integrations with other tools. And some companies had the resources to build those software integration capabilities. Some companies didn't, and they just relied on manual workforce to do that data migration from one team to the next, right? And I think that inherently added a lot of the costs and risks of developing hardware, because when you have a manual process in the place of data migration and data validation, you introduce obviously costs, time lags, risk, right? Subjectivity, inconsistencies, right? When you
Yep.
have a process. And so I think in order for us to really compress the time it takes to develop hardware and reduce a lot of the associated risks and to really pull in some of these agile workflows that you're talking about, I think it takes pressure on the software tool providers to have an option that is out of the box, that is plug and play, you know, and have extensibility so that companies can further configure it, but that they don't have to get started, right? There should be an option where you can pick your CAD package, your PLM package, a PDM package, an ERP package, and within an hour they should be able to be interoperable, right? It shouldn't be such an overhead or time-intensive task or formidable task just to get your infrastructure up and running before you can actually do anything of value.
Yeah, very good points. And sort of back to one of the first questions you posed to me about observations I've seen in my career. Worse than spending a whole lot of money bringing in professional services and introducing risk and delays, it's still happening out there. The big 5 service systems integrated that are revenues of multi-billion dollars are still customizing software products to create industrial products. So why is it still happening? And again, you correctly identify these risks and delays and all of that stuff. The worst thing is for industrial companies in going through that process is what they're doing is perpetuating the old way of doing things.
Yes.
Because they engage a systems integrator to come in and go through a digital transformation effort. How do we get from as is to to be? But they're only able to tweak a few little things. Back to lean manufacturing, if we can get 5% improvement here and 5%, they're not thinking radical, they can't, because they've got 100,000 employees and all this capital equipment and custom solutions that are restrictive and force the way.
Yep.
That's why we're seeing these miraculous startups that are coming out of nowhere with some invention that they had, the college dorm room, and they've managed to make this prototype that's now working and proving things. And they sourced it all online from their desktop computer. And they got started by cobbling it together with plug and play.
Right. Well, I think there's what's happened is there's a new culture that's entered the hardware industry.
They're not afraid of risk.
Well, they're not afraid of risk. They come with different experiences and expectations, right? So it's more common today for someone studying electrical and mechanical engineering to also formally study software development. Proper software processes, agile workflows as part of their natural curriculum. So when they enter the workforce, they're looking for tools that implement those best practices. And unfortunately, as of today, the majority of software tools are still following, in my opinion, the older model of requiring infrastructure or requiring processes or manual efforts to set them up, right? And so none of the tools are actually implementing these software workflows, and so it's alienating this new culture, and it's providing more friction, right? And so I think some of these earlier, more progressive or younger culture companies they're not even looking at the old tools. They're looking for something completely different.
They're embracing change. If I think about my career starting in the 80s in PLM, there was a sort of a culture of predictability. It was what was coveted. Maybe it was the parents' generation who went through the war. There was this culture or desire for predictability in everything about the day. Now there's a culture of wanting change. Now what is needed is change because of climate, because of geopolitical issues, of you name all the political issues on the agenda today. There's a lot of threats out there, and people are wanting to pivot, rapidly change, improve the world, reduce carbon footprint, and more sustainable ways of creating food. Farm tech coming out. Who would have thought the production of food, agriculture, could be revolutionized by technology? But it has, and that allows pods of units to be producing vegetables to be closer to the point of consumption, that reduces refrigeration and packaging and transport costs, and you get fresher vegetables, farms in a box to a table, all because of the clever utilization of technologies and unconstrained by the old way of doing things.
I completely agree with you, but what I think is leading to a lot of innovation these days, or new markets to apply hardware technologies in, is the cost to develop hardware is coming down, right? So by automating more of these data management processes that historically have been relegated to a labor workforce, it reduces the cost, reduces the risk. By shortening the time it takes to get to market, even through things like 3D printing or rapid prototyping, there's the cost to go through a hardware iteration is drastically reducing. And so when the cost to go through a hardware iteration reduces, it basically reduces the cost to fail or to make mistakes. And when the cost to make mistakes drops, it opens up ideas for innovation. People are less hesitant to take risks, right? They can try new things at a lower penalty. When the cost is high, whether it's a financial cost or a time cost, as an engineer, when I was, in working, it wouldn't be uncommon for it to take 3 or 4 weeks to get a batch of PCBAs back from their supplier, or 2 to 3 weeks to get a handful of CNC machine parts, as a prototype. And because, as a startup, 2 to 4 weeks is a long time to wait, I was less willing to take a chance or try something innovative, right? Like I would double, triple check my work. Is this going to be a functional prototype or not? I didn't have room to try things, to experiment. The cost was too high to fail. And so now that the cost is dropping, I think there's a whole nother layer of innovation that's happening. 3D printing, rapid prototyping, the pressure to get to market faster, concepts like Git, branching and merging that came from the software industry are now more common and formal and understood by hardware engineers. They can try new things with less risk, and it's easier to roll back when they fail.
Yeah, good point. I think related to that on the topic of culture, so I get it, there's a willingness to sort of fail fast and try new things and be innovative and be change agents in the world. But along with that is a human factor about trust. Because as we embrace the supply chain, this vast ecosystem that transcends borders and countries and all of that, there needs the idea of a human doing acceptance testing of some unit and looking at it and running it through the battery of tests isn't adequate anymore. Because there's no, a contract isn't enough trust these days. So we have to rely on software systems, intelligent software systems that have an algorithmic approach to scrutinizing this thing that's coming through the door that it's coming from your local wholesaler, but they got it from another distributor who got it from another country who, unbeknownst to anybody, switched suppliers last month. And now there's some new member that you're oblivious to in your supply chain. So ultimately, the designer, the maker of the piece of hardware or any product, is now responsible for fully scrutinizing, full traceability, the genealogy of that whole supply chain, and using algorithms, software tools to do all kinds of trials and situational experiments to check the authenticity of the whole working thing. Because in the end, if it's a car, a computer, something we rely on for our lives, there's a risk, there's a health, human safety aspect to this too. And we often, every few years, there's some major catastrophe where we find out there was a supply chain issue behind it.
Diving a little deeper into using people or software as part of the production, all the responsibilities. What do you see as an inhibitor for bringing more manufacturing back to the United States or other higher labor rate countries?
It's a big subject. The current administration is investing a lot in bringing microprocessor design and manufacture back to the country. So it's a mixture of things. Some things are going to be slower to change, like political rules, regulatory approval of designs, submission to the FDA or FAA or whatever. That's slower to change. But the outsourced manufacturing, factories can be stood up or repurposed, retooled rapidly. If there's a factory that's making 2-year-old hardware here, it can be quite rapidly rejigged, fixtures, retrained, repurposed to make new hardware devices. So I think, there's multiple factors. One is universities providing the right training of how to train engineers. We lost too many engineers because they went to other higher paying jobs.
Well,
they need to come back into the profession.
Do you think things through automation or robotics are going to help?
Of course, and we're seeing that. The domain of industrial robots, you think of Detroit automotive plant and sparks flying and giant. Now we're seeing domestic robots delivering food on the streets, in restaurants. We're seeing mini robots, mini rockets, smaller capacity, smaller footprint rockets and robots doing new things for a new price point to a new, bigger market.
Well, they're augmenting.
Augmenting the human factor.
Augmenting, not replacing.
Hazardous roles for people being replaced.
Redundant, repetitive tasks, rote tasks.
Exactly.
Right, and so allowing people to move on to more higher skilled, or more focused, or more variant types of tasks, where it's hard for a robot to be able to adopt.
Yeah, relying on the human factor for abstract decision making and ultimate governance. But these highly repetitive, hazardous tasks should not be the domain of people.
Yeah, we've talked about a lot of the shift in the software tools used to design and manufacture hardware, from more in-house, extensive, highly configured, expensive tools and processes to the now more agile, plug-and-play capabilities. What's next? Where's that trajectory? Where do you think we need to get to? Or what is down the road that we're going to see?
I think we're going to see agile teams. So just as we said, some of the boundaries are human organizational boundaries. The software is capable, modern cloud software is capable of creating this digital thread and fast tracking the prototyping, the failing fast, the low risk, low cost way to fail, ultimately producing a better product. People need to catch up and how people work together. We've gone through COVID. Post-COVID isn't returning people to the workplace like they were before. People are still wanting this. They're moving to Wyoming and living in airstreams on the Pacific coast and doing their work. They're attending work. So I think there's going to be more of this distributed workforce and elimination of workforces that are doing menial tasks and repetitive, labor-intensive kind of tasks. And it'll be a thinking workers' domain, and they won't be required so much to be in the office. Notwithstanding, some of the Bay Areas are demanding their workers come back in.
So one of the things that I'm seeing a shift in is how people talk about the tools they use in the hardware space. It was once more common to talk, as a candidate employee applying for a job at a hardware company, you ask, what are the CAD tools you use, right? What, am I skilled? Do I know that specific CAD package? Right? And it stopped there. But there are so many other tools that are used to get a product from design to manufacturing that aren't really discussed when you're communicating with a company or evaluating a company and their current status or progressiveness or what have you. And so what I'm starting to see is a shift, in the software industry. You talk about what's called the tech stack. What tech stack are you using, right? Which often refers to what are the programming languages, what build server you want, what's your test framework, the entire tool set. What is that infrastructure? Because there's a lot of interoperability that can happen. The software tools are evolving over time. It's kind of a subtle way of assessing how progressive or conservative the company may be. And so I think the hardware industry has to start globbing onto that same vernacular. What is your tech stack, right? What are the tools you're using at your company that allows you to move fast? Do I know those tools? Do I know those workflows? Instead of these separate siloed products, think of it more as a contiguous tool chain and data flows between any of them at any point with very little overhead or administrative effort.
You know, I think back, it wasn't too long ago, in Pascagoula, Mississippi, in an aircraft carrier dockyard, big signs advertising trying to recruit certain brand of tool-trained people. So they were inhibited by the absence, by not having enough people that were trained in that particular tool. The opposite is true now. If I look to my kids, they use Google Docs, Google Sheets. They did that through college. They would, if they were coming into Pascagoula, Mississippi, they probably wouldn't go and live there, but they would contribute to the retrofit of $1 billion retrofit of a nuclear aircraft carrier. And they would expect PLM to manage all of that, and they would expect it to work like a Google Doc, collaborative and SaaS subscription, and figure it out as you go without attending a month-long training course.
Agreed. Well, James, it's been a pleasure talking with you as always. I think you have quite a few fascinating anecdotes and experiences from your career, and I really enjoyed the banter of my experiences and how they relate to yours.
Yeah, likewise, and great conversation, and great to know there's leading companies that are changing the way we go about manufacturing products and for a better world.